So yeah, my talk is about how we turn an application UI into an API. Before I start, how many of you are nervous? OK, just me. Yeah, that joke sounded much better in my head, but yeah. So yeah, before I start, let me introduce myself. I'm Narendra. I work with a company called Twilio here in London. I recently moved to London. It's been 6 months, before which I used to work for Booking in Amsterdam, and before that in India. Basically, I started off as a 3D modeler, and then my PC crashed. Then I decided only Notepad could work on my PC, so then I became a web developer. So that's my story on how I landed on being a web developer. So yeah, before I start, I think there's one main question which I think I should address, what is an API? Everyone has a different understanding about what an API is. So what I did was I Googled, and I got a definition, which it says, a set of functions and procedures allowing the creation of applications that accesses the features or data of an operating system, application, or other services. I had no idea what it means. So I Googled again, asking what exactly is an API. And now I landed on a Stack Overflow answers, which was not the right answers according to the person who asked the question, which it said an API is the interface through which you access someone else's code or through which someone else's code accesses yours. In effect, the public method or the properties. Now that makes sense because that's what API is, or what I understand as API is. So to put that in perspective, if you're a library developers who build a particular library, this is your library code, and if you have customers far, far away who wants to use your code, they don't want to dig into your code, understand how jQuery or anything works. They probably want an interface or an API which they can interact with. So you'll probably create a layer on top of your applications, which would speak to your code from the outside world or the other way around, and through which the consumers can access your code. To give you an example, everyone has used Movement.js and decided not to use later. So Movement.js is a library code. .format is an API which people can use. You pass any parameters on how you want to format. You get the response back. So all in all, probably this is how API could look. And to put that in a larger perspective, we all are developers building any certain libraries or a product. You could use the API as a Lego block. Different products has different kinds of API. You all put together and build your own application. And that's what it could look like. So at Twilio, we've been, it's I think a little over 10 years Twilio started. We've been building a lot of products. Most of them are backend services. And everything is around APIs. So we build a product, we build a service, we build APIs, and let the customers decide how they want to use the product, and we go from there. A year ago, we decided to launch our first UI applications, a product which has UI in front. And we wanted to launch in such a way that this product works out of the box. That is, you just render a component on a top level. It renders this application. Or if they want to change any aspect of this, they can go and change. To give more detail just about what this Flex is, it's just a programmable contact centers where anytime you call any customer service, the agent's probably using this kind of an UI where the call comes in or a message comes in. They respond to that, and it's done. Now, to put that, to get the perspective smaller, to understand much better, think about a chat app. This is part of Flex UI. And this particular product has 3 components. And if you decide to build this, you would see these 3 things: header, a list of messages where the messages come in and everything, and then the message input. Now, OK, so everything works. And then you decide to ship it. You probably give the user that, OK, chat, that's our main component, main product. Render this wherever you want, and this particular UI just shows up. Everything works. And later, some other customer probably comes and tells, OK, no, I actually want the chat message list to come from outside, and you tell me when the message has been typed by the user. Cool, I'll create 2 props, which is message list. You give me the array of messages. I will show it. Either it's on the left or the right. And I'll give you and you give me the callback, which I will execute when the message has been sent. And this props is an API, right? OK, it all works. Then 2 months later, someone else comes and tells, I want to render the message differently, the message bubble differently. It could be text, it could be image and everything. And this can go on, and someone would tell, I want to replace the header. I don't like the way this looks. And the props can go on and on and on. All right? So this is a problem, and this is definitely not scalable. And keep it in the perspective of the flex, which I just showed earlier. This is definitely not scalable, where we wanted every components, everything to be programmable. OK, fine. Now I'll go back to something which I heard on the online called compound components. How many of you have heard what compound components are? Cool. This is React Advanced. Yeah. So yeah, compound components. To give a bit of gist on that, it could have. So if you have three main components, you have 3 internal components in there. You can configure the way you want each one, and then they position the way you want each one, and then just picks them as a children and just renders. It passes the props what it needs from the top level accordingly. Cool. I want to change the way message bubble works. It would be somewhere inside message list. I'll probably change the way message bubble works. Cool. So on this product, it works. But looking at how sometimes the clicker doesn't work. But yeah, looking at how the flex probably somewhere deep inside the message component did, and it could become too deep. This is the deepest tree I could make. Why did I not go with bigger? But yeah, so the example is that message bubble could be somewhere inside. You'll have to recreate the entire tree, and that's, again, didn't solve the problem. So what did we do? So this particular product is built with React. Everything here is a component. So the idea is that we want any component. So any component we want our customers to manipulate or change or replace or do anything with that, we call them as programmable component. And by programmable component, what I mean is there are 3 main functionalities which I want them to add. One is adding any custom children on any part of the hierarchy, any tree. We want to let our customers to add a children there, and it should act like it was already part of the component. It should get the right props from its parents and everything. And if you don't like any component, there should be a possibility to replace that existing one. And again, if you don't want any particular children in any of the tree, there should be a possibility to remove them. So it boils down to three main actions, which is adding, replacing, and removing. If you kind of think about it, this is what Git does. Every commit is adding, replacing, adding, removing, replacing, stuff like that. So yeah, I don't know why I said that, but yeah. Think about. So just to put that in a smaller perspective, there's a component called message bubble, and all it does is it renders a message bubble with your name, when the message was sent, and the actual message. So what we actually wanted was, now I will show you how our API would work, and then I'll explain internally how it works. So this particular thing has 2 children, which is the header and the body. And let's think about how you would add a children. So we create every programmable component would have a static property for an action, which could be .add. And what it does is it takes a component as a parameter, and it adds it to the children. So what here it does is it took the time ago, and it just renders that component. Now, this static properties can be used multiple times, and basically what it does is it stores it in its local fragments, I would say. And whenever the actual rendering happens, it picks from there and it starts rendering. I'll go about that in detail a little later. So if I want it differently, if I want to arrange it on the top or in different positions, then I could pass the sort order as -1, and it would just render it on the top. And if you want somewhere in the between, you pass accordingly which position you want the component to be rendered. And again, this component would get all the props the other children would be getting. So you can conditionally do multiple things, making sure that this component already is part of that. And how do you remove a children? So to remove a children, you need to know what children you want to remove. So time ago, header, and the body are the 3 children here. Let's say we want to remove a children. Again, we have a static property called remove at the component level. And you pass the key of the children you want to remove. And yeah, that just removes when it actually picks the render. Again, replacing, we again have the similar property, which is .replace. And yeah, so replacing what it does is very different from add and remove. Add adds it to the as a children. Remove removes a children. But replaces the entire component. Probably you could rename it differently, but yeah, for now it is .replace. And what it does is it replaces the entire component with whatever the custom bubble you have passed with. So yeah, let's see how it works. To just go back on what I just spoke about the API, message bubble is a programmable component, which is a React component. It has a static property called .add, which takes component and option as the parameter, which I just showed an example with sort order. And .remove takes the key which you want to remove, and replace takes the component, again the option. So option you can pass different other options for replaces. So what happens? So when the message bubble when the message bubble is about to render, first thing what it does is it looks at all of its children. So in this case, we have 2 children, header and body. And it takes them, it keeps them in a separate location. It makes a copy of it for simple terms. And then it looks at its local static property .fragments, _, it's a private property, where all the components which was added through .add will be stored there. OK, it takes, OK, fine, I need to add all of them as a children to this component. I'll take that and I'll keep that along with the other childrens which I have. Oh, cool, now this works. Then I'll look at the sort order. So what was the sort order which I had inserted with? By default, I have my default sort order for my existing childrens. And OK, this is -1. Then I will sort it the way it's supposed to be. Fine, I have my children. Then I look at my remove request. So every time you do a .remove on any of the key you want to remove, it stores it in a different array with all the keys of what has to be removed and stuff. So yeah, here the header has to be removed. So it removes the header, and you get the final child. So this gets rendered. So there more complications could happen at different stages. But on a top level, internally, this is how programmable components would work. Another thing which we have is called actions framework. What is an action framework? So action framework is a framework for actions. But the difference is that it's anything an action which a user is performing on the screen, or it could be anything from a backend it's happening. And it has some other functionality which I will go through. So to give an example, this is the ongoing call screen. And there are 4 actions which you could see here. One is hold the customer, mute yourself, open a directory to transfer the call, or end the call. So every time Flex is Flex is the product which I was talking about. Every time Flex is initiated, we register each of this action with a particular listener or a handler. And every time an action is performed, we execute an handler. This is as simple as add listener for any of the event which you have. So what a customer wanted was a little different. So what they wanted was they wanted to hook into any actions, and they want to perform a specific operation or some operation before an actual handler has been executed. And this could be something like, oh, OK, before the call has been disconnected, I want to check if the agent has done everything right. And if it's not, don't execute the actual end call actions. It could be something like that. Or it could be a total different implementation of what a user wanted something to do. So what we did was we gave an action.add listener, where you pass a name with before and the actual action you want to execute before the handler. And what it gets is it gets the payload of the handler, and also an abort function. So abort function could be used when you don't want the handler to be executed. And again, you get the payload, so you can do anything with the payload, and the handler would get the updated payload what you want. And same thing, after the particular handler has been executed, you want a hook where you could execute specific code after an end call has been done. So again, it gets the payload, what the handler received, and then you can execute whatever you want. And also one more thing which they wanted was they wanted to replace the entire action by themselves to their custom thing. So then we provided another API, which is action.replace action, and you pass the name which you want to replace with, and it gets the payload and also the original handler. So in any case, if they want to execute the original back, they can do that, and otherwise they can do what they want. Demo. Oh, yes. It's been 3 years since I last demoed, because the last one was so good. And that was my first ever conference talk. So what I actually did was, instead of showing Flex as an example, I forked React Tetris, which is quite popular, but in different language. So yeah, it's a simple Tetris game, which we all have played someday. And I converted them to, I kind of spreaded it around, but I converted them to programmable components. Yeah. So just to give an example, so probably the designer want Tetris, but in a different design. Either you implement it or copy-paste the code. So I'll show you how, if it was a programmable component, how would you have changed it. So fine. This is the, now I know why I'm bad at live coding. But anyways, let me just go into the React mode just to show you the DOM. OK, so the main application is keyboard. OK, so there are 4 main children in the app level, which is this. There are a couple of Twilio-specific divs added here. You can ignore that for now. There's decorator left, the main application where the game happens. OK, let me reset this. OK, that's the main app. And then the decorator right, and then the keyboard. So keyboard is, yeah, basically what you can play with. So yeah, the designer says, I don't want the keyboard. So, OK, where is my editor? It was here somewhere. Yeah, it's here. So yeah, all this Tetris game does is tetris.app, pass the store what you want, and that's it. So I'm going to say that, OK, tetris.app.remove, and I want to remove the keyboard, and the keyboard key is keyboard. OK, of course. You know what? OK, never mind. So it refreshed, and it's done. One thing I'll do is I'll bring the keyboard closer. Yeah, now it's easy. I don't have to switch multiple screens. Anyways, the keyboard is gone, and also they don't want the decorators, which is left and right, but there's no actual design. So what the designer wants is just this part, which is, OK, there's a lot of cells. I don't know how much time I have, but I can go on. OK, all they want is this matrix, and they don't want anything else. Fine, let me remove all of them. Tetris dot, I can actually copy this. And what is the key? Key. Yeah, decorator left, it's decorate left. I want to remove this and the right. So it should refresh. Yep. And they want only that. So I will remove the main and add the matrix back. I'll remove the main part and add the matrix back. OK, adding a matrix back, which is add. And I'm adding the component, which is Tetris dot matrix. And let me pass a key to this matrix. Cool. I removed pretty much everything in the UI and only added what I need, which is just the matrix. So there's nothing else. Well, this works, but the designer wants a different background color, of course. So never mind. I have a different app with the background. I didn't fiddle with the internal code, so I just passed it. OK, and now they want a different cell, of course, this design doesn't look good. So what they want is a cell, but it should be rendered differently. OK, it's a cell component, so I'll replace with my own cell. OK, tetris.cell.replace. OK, what is my cell called? Somewhere here. It's new cell. So this is nothing. It just basically gets the props, wherever it's supposed to do. And by default, it gives a normal style with the background color. Otherwise, it gives an active cell or a dead cell, which is when it actually makes a row. Cool. A new cell. And a key. New cell. OK. Let's see how it looks. Oh, OK. It's pretty much does the same job. OK, that's too loud, but it pretty much does the same job, but it's a different design. OK, but this is not a complete game. They also want a score, because the previous one had score, but they want it differently. But what I did was I'm going to add a new component in tetris.app.add, and I have a component already created, which is new score. Of course, I'm prepared. Score. I'll show you what this component does. So basically, it just renders two sections. One is whatever the next item would be appearing on the screen, and another one is a score. So this does some basic calculation of getting the points. So you can see everything is just a props, which it already is supposed to be getting. So it does get the score. And you can see here, I got 36 points last time, and the next one is this. So I pretty much didn't change anything about the business logic. All I did was the UI changes. And it all works like already part of the DOM already. You get my point. It acts like it's already there, and I've not done anything there. Cool. To make it a little bit fun, I don't know if it'll work, but what better way to try it right on the stage, right? I think it's called rules. Yeah, I'm adding a rules column. So I'm going to show what rules does. OK, it's here. It's not nice. I will add it at the beginning. So basically, what I did was I connected this game to a Twilio number. And you can all call this number and play it right on your phone. Let me reset this for a while and start the game. You press 2 to change, press 4 to go left, press right. Let's see if we can get a row right now. I hope the socket connection is making an ape. I hope my internet is working. Yeah. Oh, there you go. Someone did something. I am not doing anything. OK, they're all pressing 2. OK, someone pressed right. OK. The challenge is we make a row, and then we can all go home happily. Can we? No. No. OK. OK, good. Now what do we want? OK, I don't know why. Someone on the right, please. Yeah. OK, got to turn that. OK. Oh, no. OK. We're almost there. Right. 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 Yes. Yes. Yes, right. No, we can still do it. We can go right and we can finish it off. Almost there. Almost there. Almost there. Almost there. No, right. Yes. Thank you. I actually never expected this game would be completed. We could make a row, but luckily we did. Where's my presentation? Yeah. That's it. Thank you very much.